This video is about running one-way ANCOVA in SPSS. Here is the data set. We have pre and post-test scores. And we also have a grouping variable and with 3 groups here. If I click on the value label, you can see that there's a control group and 2 intervention groups. Suppose this is a reading intervention we're looking at. I want to see that whether the intervention has any effect on the post-test scores. So what I'm going to do is first I'm going to just use one-way ANOVA to look at the effect on post-test scores. And then after that, I'm going to run a one-way ANCOVA taking into account the pre-test score effect. So let's first do a one-way ANOVA here. So we're going to do compare means and the one-way ANOVA. I'm going to put a post-test scores here and a group here as a factor, which means an independent variable. In the options, I'm just going to check descriptives. I'm going to do others. Yeah, so just continue and OK. So in the output, we'll get the descriptives, and we're looking at the means here. We do see that the intervention groups have higher means than the control group. And in the ANOVA results here, the p-value is larger than 5%, and that tells us that the groups do not differ significantly on their post-test scores. So here, because their groups may not be the same initially, and they may differ initially in terms of their reading ability. So we want to take into account the groups, their pre-test scores. So let's first look at how the groups do on the pre-test. So I'm going to use analyze, compare means, and then I'm going to put both of these in the dependent list, and then the group in this independent list. In our options, I'm going to move this sample size there. And so we're just going to look at these descriptive statistics and continue and OK. So you will see that in the output, we will have one more table here, which reporting the descriptive statistics, which group pre-test and post-test. I'm interested here is the pre-test score. So you can see that on the pre-test, the group means are different. And so, so we want to take into account the pre-test score differences. We can use the pre-test as a covariate, so adjust the differences. And so what the ANCOVA does is to adjust the pre-test means so that each group they all score the same mean as the total mean. And they use the pre and post their correlation relationship to make the adjustment. So I do have on the slide here. So you can see that this pre-test and post-test, they are linearly related, and we can have a regression equation to show what the relationship is. And we can use the regression slope to adjust the mean differences. So I'm going to have this one here. So this is how the means are adjusted. Yeah, so we're looking at the difference between the pre-mean and the total pre-mean. And then so use the regression slope to make the adjustment. And so, for example, for control group, the control group mean pre-mean is slightly lower than the total mean. And so when we look at the adjusted post-mean, it will be slightly higher. While on the intervention group 1, the pre-mean is higher than the pre-total mean. So after adjustment, the poster mean for intervention group 1 will be lower. And for intervention group 2, the mean is lower than the total mean. So the adjusted poster mean will be higher. And so when we run one-way ANCOVA, so the premium will be adjusted, and we actually the ANCOVA, the groups will be compared on these adjusted group post-test means. So let's see how we run this in the SPSS. So here we're looking at, we are running one-way ANCOVA. So we're going to go to general linear model, univariate. I'm going to put the post-test is a dependent variable. Group is the independent variable. So it's in a fixed factors. And the pre-test score is a covariate. So in the options, I'm going to check descriptives, effect size, homogeneity test, because this is a between group ANCOVA. Then continue, and then OK. And then you will see that in the output, we will have a descriptives, which tells us how groups do on the post-test. And then there's a Levene's test of equivariance. So this is a test of the assumption that the groups have the same variation. And because the sigma value is larger than 5%, that means the assumption met. The groups have same variance in the population. So this is a test we are interested in, and this is the ANCOVA results. So the table has more information we need. So I'm going to make some adjustment on the table. So if you double click on the table, you will be able to make some edits. So on the table here, so I'm going to remove some of this information, like, so this information are not needed. I'm going to remove this. And also this total row is not needed. So okay, going to remove. And this the corrected total is actually, this is the right total. So you can actually just use total, the total sum subsquares. And once you have it, and then, so you'll be able, once you make the adjustments, and then you will be able to see that this is the a simplified, much simpler table, and these all have the information we need. And we can see that the pretest effect is significant, and also group effect is significant. So after adjusting for pretest differences, we do see that the groups has effect. Since we have three groups here, so we want to see that what is between which groups there's a difference, or between which groups contribute to the significant effect. So we'll need to do some follow-up analysis. And what we're going to do is we're going to do the, we're going to rerun the ANCOVA here. And we just need to add this one. So this is the estimated marginal means. We put a group in here, compare main effects, and we are going to use the Bonferroni here because to adjust for the multiple comparisons, and then continue and OK. And then we can see here, this is adjusted means. So this is the estimate means. So this adjust like all this. So the using the pre-means it's all equal. Is that equal? So these are looking at adjusted means to compare. And then with this pairwise comparisons, it was comparing each group with any other groups. And we can see that when we can compare control group with the two intervention groups, both are significant. And when we compare the intervention group and with the intervention group 2 is also significant, with the intervention group 2 has a higher mean than intervention group 1. So this is the one-way ANCOVA, and I'm going to also to share that to if you So this is how you write up the results for ANCOVA, and based on the analysis we just did. So this is the end with one-way ANCOVA.